Okay, yeah. So it's USD. Everyone knows what it is. It's also using WebRTC, WebGL, and Filament. I guess WebRTC is probably the odd man out, and not many people may know what it is. Essentially, it's very complicated. It's one of the largest repos I think that GitHub tracks. But what it does, it allows peer-to-peer communication inside web browsers. Supported by all major browsers. The bad thing about peer-to-peer is it kind of maxes out at 6, but the good thing is there's a lot of solutions to get around that through what they call selective forwarding units, where you're essentially acting as a peer and you go to a server and the server distributes out to the other peers. And so you're not really based on that mesh topology. So it's good because you can get around the limitations. Filament, some people here know it's a PBR renderer targeted towards like deployment on mobile and web, which is a lot different, I think, with the set of constraints it deals with than most production renders everyone here would be aware of. But as there's kind of like a lack of support of the hardware side in macOS, that's the initial side of where I got into like, oh, I got to get something working. And so those are the two big things. And then the initial project for this, it wasn't based in any video production thing. I think there's a lot of applications for it, but the initial project is kind of more of an AR, VR thing for viewing sculptures in a gallery setting where you can communicate with those around you. And so peer-to-peer is totally fine because the room size is going to be 5 people, and it's going to be a local network. So we're working in those constraints. What was also important was we wanted to deliver images either in the browser or in an app. The browser, could have some deficiencies, but we didn't want to have people download something. Like there's got to be an immediate thing. I go to it. I want to see if I want to invest the time to download and continue on this experience or whatnot. Those images should be perceptual similar. So you can't really have like totally disparate renderers, which is where Filament also was a big win in that it can do WebGL and it can do a native implementation on devices. The final thing was just talking with the artist and going back and forth. It was kind of important that the assets in context of either Houdini or Maya would be rendered as they were displayed. Like the render is the same for the in-app, it's the same for the browser, and it's the same with whether you're in Maya or not. So those were the kind of the constraints where this all began. And then I guess I'll just roll. So this is just going to be, it's just a web browser. It's very similar to what Philippe did, but we have native delegates working. So it's hosted locally, but it's all through remotes, and you can just load up a variety of different native delegates. At the bottom, you'll see you can go into Python, and that's more on this server architecture. It's unclear whether you'd really want that in a larger scale setting. If you were deploying something like this to a studio, I think it'd be perfectly acceptable to just kind of have that, and it would work probably pretty well with the notebooks and stuff. Because it is all it's a pure web API at this point. So you can do these things where you can embed any asset viewing with any render you want, if it's a Hydra delegate, into something like Shotgun, into any database, and just the front end being pure HTML. And this is me, it's not just view, you can edit. And I think we get tired of Embry is very nice and it's ambient occlusion, but it doesn't support textures. So we're gonna switch pretty soon, I think, to Filament, which is in the initial. So this is gonna be Filament running and delivering its pixels. Like everything now is delivering its pixels over WebRTC into the browser. And so this is Filament just doing the same thing. It's the metal back end of it because it's running on Apple. And all the user state kind of works the same in any kind of Hydra stuff that you would do. At that, I think soon there's the wonderful kitchen always. All of this was done on one computer as well. So it's screen capturing, encoding, rendering, and decoding. So it's fairly performant, if you're just doing the one thing. And so we're loading PRMan. And, And then here at the end is kind of this idea of we want it, which it's not germane to, I don't know, it's hard to see how this is going to play out, but it's more the idea of we wanted the renderer to be the same between the, whether it's a standalone application or the web. So here, this is no longer Hydra. We're going to like actually pull that USD out. And now we're feeding this WebGL, that's like a WebGL render of filament natively. And so you're not really using WebRTC anymore at that point. Like you'll probably still have to establish some initial connection, or that's also the overlap of what Philip had done, where you could, in theory, get that done through an asynchronous operation that you don't have to go through WebRTC at all. And so that was that. And then the nice benefit of this was you have kind of like, you have a shared document state that multiple users can connect. You can see it's two different laptops I'm on, but they're both viewing and affecting the same scene. So essentially, you have, two different users.
This is awesome.
And so this part, it definitely comes from this idea of like this gallery I setting in before, but it's pretty clear, like when one of the first talks or one of the first things that come up is like, oh, asset browsers and everything. You could have two people working on the same exact thing in remote locations, like Box 3. I think right now I've switched over to a phone. I'm just not like streaming in the pixels from the phone. But Box 3 could easily just be, the main viewport is just what you're building. And Box 3 could be a totally separate also view onto different USD scenes that you're just kind of like dragging and dropping things in, and everyone's, working on that shared document state.